All right. So one of the aspects that we had just mentioned as class had begun is we have a rough estimation on next week. We'll formally assign your vocabulary due on the 6th, 6th, okay, which is, of course, Wednesday. We'll also have perhaps your first assignment. That is what we think we will be doing. And as you can see, we're adding a new problem here. And as students were writing this down, I had mentioned that it's these types of problems that just cause a lot of fits for students. Now, could it be the understanding? Yes. Could it be the lack of attention to detail? Maybe. Could it be the lack of effort? Maybe. Could it be our attitudes towards this? Maybe. It could be a variety of aspects, okay? But it's one of those that we want you to be prepared, and critical thinking skills, would that be a way of looking at that, Mrs. Herbert? And perhaps a good work ethic, would that be a good way of looking at things? Having a good work ethic moving forward, okay? At least that's what we try to emphasize here. Now, whether you receive it that way, that we don't know. Okay, so as we were saying, wrote this problem last year, and I guess I don't know how or why we came up with this example. Probably because the good school is located up here, not necessarily the high school, but the blue and gold. How's that? Go big, go blue, go Jacks. That's right, go Jacks. All right. So with this information that we see, okay, sometimes the best thing that you can do is maybe write up a sort of diagram for this to try and maybe make sense of this. And again, it is a choice to do that. So with this, you'd be looking at this and say, I have no idea what to do. Some of these variables look familiar, and the reason that you don't know is because you have not been taught this yet. Okay? So after we've been taught that, or taught this content here, we hope that it gets a little easier, that the next time that you see this. So maybe the best way, like we said, is to maybe make a sketch of this. So what this means is this wedge or this triangle sitting on the side, okay? There's no way I'm that good at drawing into proportions what it would look like. But see, that's not even standing up straight. What kind of inclined plane is that, right? Okay. I don't know if that's any better. But this is what we mean by this wedge or inclined plane. Okay? So ideally, that's kind of like an obelisk. But this is supposed to be what we're talking about here, this ramp. Okay? It says, while moving to Brookings to SDSU, Reese uses a ramp on the moving truck, or it's actually on the back, okay? Now, whether she actually did, probably not. We just wanted to use this as an example. She places a box on the 7-meter ramp that is 1.10 meters high. The box has a mass of 240 kilograms, okay, which we're talking about 400 pounds here, give or take a little bit, okay? Give or take a few pounds, okay? So with that, it would be really, really difficult to move a 400-pound box from the ground to the back of the truck. Maybe it's a tote. You use whatever it is that you want. I just put box on here just because that's what makes the most sense to me. Plus, it's only 3 letters long, okay? So then the box has a we just read that, 240 kilograms. She moves the box with 820 newtons, okay? So what is the ramp's efficiency? All right? Because what we're going to see happening here is add this to your formula sheet. We just do EFF, okay? That's an abbreviation for what do you think?
Efficiency.
That's right, okay? So then the efficiency of this inclined plane equals, okay, it's going to be a fraction. All right? So this fraction then has these variables. Okay? The goal is to not put this in this glare, and I see I epically failed, but it says efficiency equals FR times DR divided by FE times DE. Okay? So the capital letters, we hope, look familiar. Because what do you think well, not capital, but we've seen things like this before. These are supposed to be subscripts. What I mean by that is it looks familiar from this. Okay? Oh, no, we can't do that. We got to have it straight up and down. Sorry, we forgot. Okay? So, again, these are like we call subscripts, and that's what that's meant to be up here. Okay? So what that means is a large F, lowercase r, just like with your velocity. So what would you guess these F's are? Those are your forces. What would your best guess on what D is? It's going to be a distance. So there's going to be a resistance force in this equation. There's going to be an effort force. That's what E and R stand for. There's going to be a resistance distance and then an effort distance in this system or inclined plane or whichever, however you want to explain this. So we have this inclined plane and some things that we can do. It says, how high off the ground is that the back of the ramp? What does it say in the problem? Oh, that's not how high it is. Yeah, so it says, okay, the ramp is 1.10 meters high. So that means that's got to be off the ground. So this is 1.10. Okay. This, I would suggest that you do, yes. And it might help you make sense of this. So how long is that inclined plane then? Just need to be a little more confident when we say it. Yeah, 7. Okay. Now, do these have what I'm drawing here, Mrs. Herbert? Does this have a specific name? These what do you call them?
I don't know. Squiggly lines?
Well, you could say squiggly lines. What do you want to call them? Crown? Okay. I mean, that makes just as good a sense as anything else. So this crown then, okay, is illustrating how long this ramp is, although it's not very efficient because we got that little bump down there. We'll try to remove that. Well, okay. Well, we get the idea. So that is 7, okay? I forgot my label there. It's actually meters now. So then what we see happening here is as you walk up this ramp, we're going to put this box on here that has a mass of 240 kilograms. Okay? So anytime we see a mass, how can we get a force from that? Because what does force equal? Okay? So what could you presume that with the mass of this box, we said probably weighs about, what did we say, 400 pounds. I just threw that number out there because there's 2.2 pounds for every kilogram, so you just basically multiply this by 2. So how do we get a weight from that mass? You're going to multiply the mass times
The
what?
width
No.
by the height?
No. So what acceleration do we know?
Force divided by mass.
Oh, no. Well, you could, but what we're saying is we know that you have force equals this, correct? But what can we presume that that variable is that gives every object weight? 9.8, that's right. So this acceleration then is due to gravity. It almost looks like a 9. It's supposed to be an A. So we know that we've got this gravity pulling down on this box, okay? And that is 9.8 meters per second squared, okay? You might think, my gosh, when are we ever going to get to solving this problem? We're close, all right? Because what is it that we have a force moving in that direction? In other words, you have Reese pushing at the bottom with this, and how much force is she placing into that box? 820 newtons. So that's what this arrow is illustrating. 820 newtons. Okay, now you might think this is making no sense. We're about to wrap this up now. In other words, taking the next step. So we have our formula. We've read the problem, providing we wrote it down, or if we're following along. The next thing we should do is write down what? For the 20, are we 25 now? 26. For the 26th time, okay? What should we do? So we have this diagram, and we have these variables here. What do you think we could put down for, we'll do FR, DR, FE, DE down here. And then the efficiency, that's what we're looking for because we don't know. So how long is Reese going to be pushing up this ramp? For how long? What's the length of the ramp? 7 meters. So that means you'd be pushing with an effort into that box for 7 meters. So of these 4 variables, which one makes the most sense? Okay, so it's going to be a distance. So we got it down to 2. Now notice we said pushes. Okay, so that must mean, is that going to be an effort distance or a resistance distance? That's going to be an effort distance because you're placing that into the length of the ramp. You are pushing for 7 meters. That is an effort distance, so 7 goes here. Okay? So then how much effort is Reese putting into this box? So then, since it's measured in newtons, we know that's got to be one of 2 variables up there. It's got to be a force. So if it says that she moves the box, she's putting that much force into it, does that sound like a resistance or an effort into the box? That is an effort into the box. There's your effort force. 820 newtons. Okay? So then, what is it that's pulling down? That's why this diagram hopefully helps you. Yes. All right. I mean, are you doing okay with this? Okay. Yeah.
Acceleration for 9.8 meters per second.
It is, okay. So since we have that pulling down, okay, the resistance distance is only 1 left because we've accounted for this one. What's the only other distance that we see?
1.10 for distance
Okay.
resistance.
That's right. So 1.1 goes here. Then we're out of numbers, but we need to find a resistance force. But that's tied into what we talked about earlier here. How can we solve for a force with these 2 variables? Right. And actually, I failed you as an educator today because there's one number that we did not account for. Can anyone see which one it is? It's the mass. Yeah, that's where I let you down. 240 kilograms, okay? And there's also another number that we know of, this one right here. It's how we get that variable, which is your acceleration, 9.8 meters per second squared. So if you multiply these two numbers together, like we talked about earlier, that gives us a force. And that's going to give you your resistance force. Because remember, gravity is pulling down on that box. So that's why that is a resistance force. So we can take what the formula tells us to do, 240 times 9.8, and that gives us what for a resistance force?
200 and,
No, it's got to be bigger than that.
2,352.
And that is measured in newtons. So now that we've got all four of these variables in place, we just do what this formula tells you to do. And there's no label for this. It's just a percentage. Okay? So we have all four variables set up. So let's go ahead and finish that. Wondering which, I can use purple, I think. Go Minnesota. They play Sunday night, don't they? Go Minnesota. They play, I want to say Los Angeles. No, they played, Indianapolis. They play them Sunday night. Okay. So let's do what the formula tells you to do. What do you suppose that means? All them parentheses. You're going to multiply all of them. So now that we have our formula that we wrote down in our formula sheet, now that we have this set up like we wrote down from the problem, now you're on the home stretch. So what goes in this bracket right here? But the number though? 2352. What goes in this bracket or parenthesis?
1.10.
1.10. What goes in this parenthesis?
7.
Okay. And if you had these flip-flopped, it doesn't make any difference because you're multiplying. And we said 820. Okay. So then how would you finish this? What are you going to do with these two numbers you correctly said? You're going to multiply those two. So we've got 2352 times 1.10. Okay. We get 2587.2. 2587.20. And then 820 times 7, 5740.
What? For the bottom one, I got 1960.
Okay, so, just look at it again. 280 times 7, that's giving you 1960.
Oh, no, now I know what I did.
Okay.
Supposed to be 820, not 280.
Okay. Then once we get this, now you're really on the home stretch. Okay, 2587.20. Oops. 2587.20 divided by 5740. Darn it. punched it in the calculator wrong. I know I did that. Okay, so somewhere around that what we got? You came up with a decimal, I know, but we express these in percents. So that decimal, you multiply by what to get your percentage? Multiply by 100. So you move the decimal place to the right 2 times. You come up with 0.45, but to change that to a percentage, you make it 45%. Okay? Do you come up with 0.45? When your classmate gets back. Yes, what?
0.45.
Yeah, so you would multiply that by 100, and that's why you get 45. That's where that comes from. All right. So then once you figure that out at 45.45, change it to a percentage. That's 45%, and it's just a number. There is no label for it. It's just 45 with a percentage sign. Okay, so we have a little bit left to do with our unearthed video. That's where we'll stop. So we will continue that video here shortly. And then, like I said, next week we have your first assignment in your vocabulary, and we will see how that unfolds. All right, that's all I have. We will catch up to you next time.